Dear students, as we are discussing some of the examples of the Fourier series in the different interval, in continuation of the same, let me explain the even and odd nature of the given function f of x in the interval 0 to 2 pi and associated Fourier series. Observe the interval 0 to 2 pi. I mean what here? Initial point is 0 and the point is 2 pi. This is the particular interval. This is the particular interval. Hence, we shall go for the definition of even and odd function in the interval 0 to 2 pi. We know that f of x is said to be even if f of 2 pi minus x equal to f of x. Earlier we have discussed that even function f of x is said to be even if what? F of minus x equal to f of x. Because there is no interval. That was the general condition. Now we are discussing in the particular interval 2 pi, 0 to 2 pi. Therefore, f of 2 pi minus x equal to f of x, then f of x is said to be even and odd if f of 2 pi minus x equal to minus f of x. Observe this example clearly and neatly, because we are discussing even and odd nature in the interval 0 to 2 pi. Hence, by the property of the definite integral, in view of the same property as we discussed in the previous class, integration between 0 to 2 pi f of x dx equal to 2 into 0 to f of x dx if f of x is even and if is equal to 0 if f of x is odd. This property is already known by us. We are using the same property. Then if f of x is periodic function of period 2 pi defined in the interval 0 to 2 pi, then the Fourier coefficients are given by, in the interval 0 to 2 pi, then the Fourier coefficients are given by what here? A0 is 1 upon pi between 0 to 2 pi f of x dx, an is equal to 1 upon pi between 0 to 2 pi f of x cos nx dx, and bn is equal to 1 upon pi between 0 to 2 pi f of x into sin nx dx, f of x into sin nx dx. And now we shall observe these are the general Fourier coefficients. Now we shall implicate the nature of even and odd nature. Okay, therefore the first case is related with f of x is an even function. We know that the product f of x cos nx is the even function. How it is? Because f of x is even, cos nx is already known fact that it is even function. Product of the even function is what? Again even. Hence it is an even function, and f of x is into sin nx. That is what? Product of even and odd. It will be odd function. Hence the Fourier coefficients are given by, observe here, this is the general, not the general, this is the particular even, particular case related with even function. The interval will change here. Therefore, a0 equals to what? 2 upon pi into 0 to pi. In the general condition what you have taken, it is 1 upon pi between 0 to 2 pi. This is the general condition. This is a particular case when f of x is an even function. Hence a0 equals to 2 upon pi 0 to pi f of x dx, and an is equal to 2 upon pi 0 to pi f of x into cos nx dx, and bn is equal to 0. When f of x is an even function, we can definitely claim that bn will be 0. We need to evaluate only a0 and n in the respect to interval. Case 2, when f of x is an odd function. Here we know that f of x is odd, sin nx is odd, product of two odd function is what? Always even. Hence f of x sin nx is it is an even function, and f of x into cos nx is an odd function, because product of odd and even is what? Odd function. Hence the Fourier coefficients are given by bn is equal to 2 upon pi between 0 to pi f of x sin nx dx, and obviously a0 and an will be 0. Observe this condition. Hence it may be observed that this interval, this is the very particular case where f of x is bifurcated into two sub function in the respect to sub interval. F of x equal to phi of x in the interval 0 to pi and is equal to psi of x in the interval pi to 2 pi. Then we say that f of x is an even function if phi of 2 pi minus x equal to psi of x, and f of x is an odd function if phi of 2 pi minus x equal to minus psi of x. Observe that here phi of x is the first function, psi of x is the second function, and the ultimate interval will be what? 0 to 2 pi. We are dividing 0 to 2, the interval 0 to 2 pi into two sub-interval. One is between 0 to pi, another is between pi to 2 pi. Using this fact, let me take one example, and that example will be f of x equal to x square in the interval 0 to pi and minus of 2 pi minus x bracket square in the interval pi to 2 pi. Absolutely what happens here at the end, it will become 0 to 2 pi, the interval. Hence, comparing with the above property as we discussed in the previous case, phi of x will be what? The first function is x square, and psi of x will be what? The second function minus of 2 pi minus x bracket square. Now we need to discuss whether it is an odd or even. As we discussed in the earlier, phi of 2 pi minus x equal to minus psi of x. That is what? X is replaced by minus. Hence it is 2 pi minus x bracket square. It will be minus psi of x. Hence f of x is an odd function. Observe here. We need to recognize that whether the given subinterval is related to either even or odd, then only it is possible to go with the solution of the example. Always refer, this is the special condition. Hence in the interval a0 and an will be 0, and only bn will be what? 2 upon pi between 0 to pi f of x into sin nx dx. Observe that f of x is an odd function. My dear students, refer this condition. Therefore, only we need to evaluate bn, and therefore bn is equal to what? 2 upon pi between 0 to pi x square into sin nx dx. Hence, the interval is followed by again Bernoulli's form of the integration. What is the Bernoulli's form of the integration? U is equal to x square and v is equal to integration of sin nx dx. What is the Bernoulli's form of the integration? We will denote u v1 minus u dash into v2 plus u double dash into v3 and so on. I am observing the same condition, 2 upon pi, keeping it outside, u is equal to x square. Integration of sin nx is what? Minus cos nx upon n, minus, because the second term is started with a minus sign, and u dash is what? Differentiation of x square, it will become 2x, and integration of minus cos nx upon n, it will be what? Minus sin nx upon n square, plus the third term is related with plus sign, and differentiation of 2x becomes what? 2, and integration of minus sin x upon n square will be what? Cos nx upon n cube between 0 to pi. Therefore, 2 upon pi, again observe that sin n pi, sin 0, 0, hence the second term itself becomes 0. We need to consider only the first and third term. Therefore, minus 1 upon n into pi square cos n pi minus 0 plus the second term becomes 0, and the third term 2 upon n cube. Why it is minus 1 upon n the first term? Because minus into 1 upon n. And the third term 2 upon n cube into cos n pi minus 1. Why it is minus 1? Because cos 0. What is cos 0? That is a 1. It is the minus is between difference of upper and lower limits. Therefore, after simplification, it will become 2 upon n minus 1 raised to n plus 1 plus 4 upon pi n cube minus 1 raised to n minus 1. Hence, f of x, putting only the bn in the f of x, it will be the required Fourier series coefficient. My dear students, I am observing that some of the students are not responding me in this whether the Fourier series is understanding by you or not. My suggestion is to start with the examples from the first day. Go for practicing it without pen and paper. Do not do anything. Just do not read it. It is not possible to get the solution. Just with a pen and paper, practice all the things, then only you can come to the conclusion that the examples are very simple only with respect to the perfect integration. Okay, thank you.